Okay, YouTube, in this video I'm going to really quickly show you how to convert from rectangular coordinates to polar coordinates and vice versa, polar to rectangular. And I'm going to tell you this, the key to this entire video is that you'll want to draw a picture of every single possible situation. But basically, let's go ahead and represent one really quick picture here. Let's just go ahead and say that we have some point xy in the coordinate plane. And I'm going to represent this in rectangular form. That is, we already know that this distance down here is x and this distance here is y. Essentially, we want to relate r and theta, which r is this distance from here out to the point, and theta, which is this direction angle here, to x and y. So our relations are going to be listed as, these down here, but let's go ahead and start with polar to rectangular. Polar to rectangular, essentially, we're saying that all of these points on the outside here, polar, we would already know some direction, we would know some angle here. So if we knew theta and r, we say, well, what we want to find are x and y, then basically what we could say is, well, then the cosine of theta would be x over r. And likewise, we could say, well, that x equals cosine of theta times r, so we say r cosine theta. And we could just basically solve for that using SOHCAHTOA, and then likewise we say y would, we could relate theta and r to y by saying that the sine of y, which is opposite over hypotenuse, is y over r, and taking both sides times r now, we have y equals r times the sine of theta. So essentially we would say all the points around the outside of this here are just basically r cosine theta comma r sine theta. That's what they are. Okay, so we have the horizontal and vertical component of every point. And that's basically what you're seeing here. It says, if you want to know the x value of this point, you would just say take the radius value times the direction angle, the cosine of that, okay? And then rectangular to polar, let's say I already know x and y, I want to find r and theta. Well, if I wanted to find r and I already know x and y, we would say that x squared plus y squared equals r squared. So if this is the case here, I'm going to give you the abbreviated form. We're going to say it's the square root of x squared plus y squared. And this is always very true. And then we say, well, how does the angle relate to y and x that we would know here in rectangular? Well, we would say tangent of this is y over x. So we would say it follows that then our theta is equal to the tan inverse of y over x. So let's go ahead and put these to use essentially. I think that you're going to see this best if we just go ahead and do it. We say let's go from polar to rectangular. I give us a couple of numbers here. So you notice I put some polar graphing grids up here and we say, well, 2 comma pi. We would go in a pi direction, which pi is going in a 180 degree direction from the polar axis. So we would say we go 2 units out in that direction. So we would say that this right here, is 2 comma pi. And I'm going to label this here, 2 comma pi. What we want to do is we want to represent this in xy, terms, x and y. So we would say our x value and our y value, let's get used to this here, but we say x and y in terms of r and theta, we would have 2, which is our r value, and we say cosine of pi. And then this is going to be 2 sine of pi. And this is going to be kind of easy here because if you know your unit circle, you know that it has a radius of 1. And that when you're talking about pi, which is located right here, that this point negative 1, 0 is going to tell you your cosine and your sine respectively. So cosine here looks like we get negative 1. We get 2 times negative 1, which is negative 2. And we say our y value then would be 2 times the sine of pi, which is 0. We get 2 times 0. And we get 0. So what this means is our point here is basically negative 2 comma 0. And I would say that, dear audience, can you see how that would be negative 2, 0 in the rectangular coordinate plane? I'd say, yeah, I think that most of you can. So let's look at one that is not so clear in the rectangular coordinate plane, but we say root 3 comma, pi sixth. So pi 6, we know that's about the same as a 30 here. It's a sixth of the way rotation over to pi. So we'd say that it's along this radial arm here. We say root 3. So we say root 3, here's 1, here's 2. It's a little bit less than 2. So I hate to do this to everybody here, but technically, it's not very long here. We'd say that, and I'm going to label this here, we say r is equal to the square root of 3. If I was zoomed in more, we could see that we've gone out 1 and some change. And we know this rotation angle here is pi 6. That's this entire radial arm right here. So this right here, what we want to do is represent it in x and y. Well, what I'll tell you is if you've drawn a picture of it, maybe the best way to draw a picture of it is really this way. We'd say that this is right here pi 6. Or 30 degree angle. And we know that the r value here is the square root of 3. Then what we're really trying to find are x and y. And I want everybody to know that you could just do this using SOHCAHTOA here. But if you've written these things down, then what we're saying is, well, we've already got these equations here that are going to be we'll want to use them often. So again, we say x. X is going to be r cosine theta. So we have an r value of root 3, and we have cosine of pi sixth. And then we say the y value of this point, whatever it is root 3 sine of pi sixth. Okay. Those are the components there of this point in terms of x and y. So when we figure this out, we say sine of pi 6. Let's think of our unit circle again here. We say pi 6 is right here, but we say pi 4 is pi thirds. We'll write all these out. I know I'm not drawing them very clearly here, but the thing is that all of these have in common that they're all over 2. So this is over 2 here, and I would say that it goes 1 root 2 root 3. So this is root 3 over 2 comma a half. So we would say the cosine of pi 6th here is root 3 over 2. So we get root 3 times root 3 over 2, which gives us root 3 squared, or 3 over 2, which is just equal to 1.5. So we'd say 1.5 is our x value here. This is 1.5. And then we say our y value, we say, well, the sine of pi 6, the sine of pi 6 is just going to be this half. So we get root 3 times a half, which is root 3 over 2, and that would be root 3 over 2. That'd be the x value here. So we would say that really the point here, this point here in rectangular form is going to be an x value of root 3 or root 3 over 2, 1.5, okay, so 3 halves, and then root 3 over 2. So there's its rectangular form. So let's look at one example. We go rectangular to polar. This one's a little bit easier to sketch. Like I said, always draw a picture. We go left one, up one. And what we're really trying to do here is this. We already know I've gone left one and up one. We can draw our triangle in here. We want to find what is our r value and what is this direction of rotation, this theta here. So we say r value is going to be the square root of negative 1 squared plus 1 squared, or the square root of x squared plus y squared as per our formula down here. So we get the square root of 1 plus 1, which is the square root of 2. So we would say, if I'm going to write this in polar form, I'm already aware that I've gone root 2. And we say, well, what is this direction over here? Well, anybody that knows that this is an isosceles is going to tell you this is a 45-degree angle right here. And if that's 45, then this angle here is 135. But I'll tell you what, without eyeballing this, how could we, actually figure this out? We say, well, then the y value here is 1, and the x value is negative 1. So we get then the theta value, which is this thing we've written right here, is equal to the tan inverse of our y value 1 over our x value negative 1. And if you turn on your calculator, you say, okay, well, negative 1 is 1 negative, and we want it'd be the tan inverse of this. We get negative 45. Basically, what it's telling us is this the reference angle over here is 45. So again, this is 135 here. So we say that that point right there, this point, negative 1, 1, could be written this way. And again, 0, 2, I just want to bring this one up because if you go 2 to the right of the origin right here, and I say, well, what point is this here? Well, we already know that r is going to be 2, and we already know that the direction angle here is 0 degrees. So we would say that this is the point, well, 2 comma 0 degrees. But, again, if we said r is the square root of x squared plus y squared, you get 0 squared plus 2 squared. I should really be putting those in parentheses. So we get the square root of 2 squared, which is 2. And then we get the direction angle here. We would say, well, that'd be the tan inverse of 2 over 0, which tan inverse of 0, you go over to this point here on your unit circle, we'd say that tan inverse of 0, tangent is 0, or 0 over 1 here, it is 0 at this point. So we say that this angle is 0 degrees. So we could figure this out, the hard way or the easy way, but that's how you convert from polar rectangular to polar. Cheers.